So this is good news. I'm running through my spectrogram with I've got my selection table start times and it's actually working. And what I want to do is generate a bunch of images for a machine learning model to train it on, and I've got that. I've got however long. Let's see here. How long is that start times? I've got 447 songs just in this file alone. And if you can see over here, I've actually got a whole bunch of wave files. So I can quickly generate thousands. I think my model, I did 36,000 total images, which might even be too many, depending on different factors for machine learning, like overfitting and stuff based on the birds I'm using and whatnot. But it's good to have a lot of data. That's generally the constraint is you don't have enough data because data's sometimes hard to get. So I'm going to go through and actually cut these into images. So rather than just display them as spectrograms, that's just to check in. I actually want images being stored in this folder. So I've created a new folder here. Let's give that a variable name. It's called new folder. And I want to cut at these start times. I'm still iterating through this whole array of start times, and I want to just slice up an array and grab just that little bit of the 2D array. And so I'm going to need that conversion ratio again to get the columns. So let's say I want the start column. I'll just call that start I, because I is what I'm using to iterate through. Or maybe we'll go start call. And that's going to be time times my conversion ratio. And I want that to be an integer because I'm going to use it to index a column. And so it needs to be an integer because columns are integers. And then the end column of whatever array I want is going to be the start column plus, say, let's go 1.5 seconds, because these songs tend to be 1.5 seconds. And again, I want that to be an integer. And so let's maybe just print start call. And sure enough, yeah, I get different columns. This is going to be the first 6 times that are turned into columns. So that's good. And now what I want to do is cut out an array from my spectrogram. And it's going to be all the rows, but it's going to be start column to end column. So that's going to give me an array. I can even print that. And sure enough, I'm going to get 6 different little arrays. And it'll be the shape. It'll be 1.5 seconds long, however many columns that is, and it'll be all the rows. So 623 rows, I guess. And now I want to turn that array into an image. But before I do that, I want to switch it into the kind of PNG format. Because right now what it is, it's in -80 to 100 decibels. So each of these is, you can see, the values range from -80, and then the max would be 0. Well, that's useless for an image because images are usually, in this format that we're talking about, are from 0 to 255. So how do I go from a range that's -80 to 0 to a range that's 0 to 255 without kind of muddying, like without muddying up these images? I want to take and have it still be the same image, just in a different format. So what I can do is just take my NumPy array, and I'm going to add 80 to it. So now it's going to always be between 0 and 80. And I'm going to multiply it by 255 over 80. And that's actually going to just change that array to be, so you can see right now, if you look at them, they're -80, and they go up to 0. You can take my word for it. A lot of them right now are really quiet. You can see there's -33 here where the song is. And I do this, and now 0 is now the minimum, and the loud values are kind of on their way to 255. The loudest moment in the whole thing will be 255. So it's kind of like normalizing the data, but or converting it into the type of range that we want. And now I can convert it to an image. So let's say, what do we want to do? We're going to take from the image library, from array, I believe is what the thing is called. Yeah, I don't get an error, so it seems I remembered that correctly. And I want to convert this image to, I'm going to convert it to RGB. Again, am I remembering correctly? I'd get an error if I ordered those wrong, so that's good. And that's just because the format I'm using in the machine learning model is the RGB format, just because that's kind of what I had. And so you just got to be aware of what format that you're using on the other end. Like, what's your destination format? It might be whatever tutorial you're following or whatever is using a certain format, so you just kind of shoehorn everything into that format so that it works with the tutorial you're watching, and then maybe you learn more and you realize, oh, I could have used grayscale or something like that, and that's fine too. But this is working for me, so I'm converting it into the RGB, so everything's always going to be in this format. Essentially what I need is that it all be in the same format. And then let's say we're going to save it, and we're going to put it in this new folder. I'm just getting the title of my image. It's going to be a PNG. Let's say .png on the end, and I'm going to have it be, let's say, image. Let's put that outside on the f string and go image I, and that way they each have a different name. And this is kind of ugly, so I'll put it there. And now it's in this string, and we need a slash. Okay, so if I do that, hopefully I don't get an error. I don't. And if I go up and look into my new folder, I've now got 6 images. If you don't believe me that those weren't there before, I'll just delete them, and you can see I'll run the code again. And I might have to refresh it. There we go. So now I've got these little cutout spectrograms and the different hermit thrush songs. So now I'm getting data for my machine learning model. And of course I don't have to stop it at 6, or when I is greater than 4. I could run the whole thing and fill this folder with 447 images. And then if I, because I have more than just that one file, I could actually bring in all these wave files with all their selection tables. I think I would use glob for that. That's a library, a Python library that is good for managing files in folders. And I think when I did this originally, that's what I did, is I used glob to bring in all the files and run the for loop like this that cuts them out and saves them. And essentially this new folder, and that's a terrible name for a folder. This is our positive songs, let's say. So our positives are in there. And then the next video, I'm going to show you how we're going to grab the negatives, because that's not quite as intuitive, because we have a selection table of a bunch of positives, a bunch of actual hermit thrush songs that have been selected by a human. And then we're going to ask ourselves, okay, but we want a bunch of negative. We want some garbage. We want some stuff like this to put in and compare to the other ones. Stuff like this that's only got half of a hermit thrush song in it. Or maybe stuff like this where the hermit thrush song isn't at the beginning. So we want to generate a bunch of garbage. Maybe you can already think about how that might be done, but that's what we're going to do in the next video. So stick around and check it out.